Welcome. Today we'll be working on general math concepts that could be needed for various forms of interview, like an aptitude test or entrance test to any kind of profession. So the first thing we'll be talking about here is fraction. Yeah, fraction. What's a fraction? A fraction is a part of a whole. For example, let's say you have 5 oranges and maybe you've eaten 2 out of the 5. So that is 2 out of the whole, which is 5. So we're going to treat, if let's say there's a question that say, okay, if, let me call it an example. Example, what fraction remains when you eat 2 oranges out of 5 oranges? So what fraction remains? So to get a solution to this one, we can say, excuse me. So we say your the total oranges you have is like a whole, you know, the whole is 5. But you've eaten 2 out of 5, so minus the one you've eaten, which is 2 out of 5. So how do we get what fraction remains? The fraction that remains is going to be, obviously, out of 5 you've eaten 2, so it's 3/5 that remains. But how do we get that mathematically? Since this is 1 and it has no denominator, we can introduce 1 under it. So if we introduce 1 over 1, so we have two denominators now, 1 and 5. So I can try to, maybe I should write it again. So what I have was 1 minus 2/5. So, but because I need a kind of a denominator, so I put over 1 here, then I will have to pick 5. You pick 5 as your common denominator. Why did I pick 5? Because 5 is a multiple of 1. Let's assume this is not 1 but 2. You cannot pick 5 because 5 is not a multiple of 2, but you look for the next multiple of 5, which is 10. Fortunately, it's a multiple of 2, then you pick 10 in this place. But what about if this is another kind of number like 20 here? If this happens to be 20, then I'm not going to pick 5 again because 20 is now the bigger denominator. So it's a 20 I'm going to pick. Unfortunately, I can use a 20 because it's a multiple of 5. So I can use a 20 here. So what am I going to use it for? That's what we want to look at now. How many 1 goes in 5? That's 5. 5 times 1 is 5. Then how many 5 goes in 5? That's 1. 1 times 2 is 2. So there you go. 5 minus 2 is going to give us 3/5. You've eaten 2 out of 5. Then it remains 3 out of 5. So that is basic fraction concept. Okay, we're going to continue shortly. So the next thing we want to look at is adding fractions. And we're going to look at examples how to add fractions together. Let's say you have this question 1 that says 2/5 plus 3/5. Like the example that I gave you, I said you ate 2 oranges out of 5 oranges, and you have 3 oranges left. So if we add 2 over 5 plus 3 over 5, it's supposed to give us the whole number of oranges, the total number of oranges, which is 1. So let's see how this goes. So how can we do this one? You find your LCM because they are the same numbers. You pick one of them because there is no bigger one now. So how many 5 goes in 5? That's 1. 1 times 2 just means 2. So you use the denominator to divide this one. Then you now multiply by this one. The same thing you do on the other side. How many 5 goes in 5? That's 1. 1 times 3 is 3. Then you have 2 plus 3. That is 5 over 5. And 5 over 5 is 1. So with that, you have done the first kind of addition and fraction. We can also have to say, okay, 2 over 7 plus 1 over 7. Yeah, since they are the same denominator, all we have to do is to pick one of them. No? Then say, how many 7 goes in 7? That's 1. 1 times 2 is 2. Then 7 goes in 7, that's 1. 1 times 1 is 1. So it looks as if you just add your 2 plus 1 or you add your 2 plus 3 without considering the denominator. But that's not the case. The case is that they are the same denominators, so it looks easy. Then number 3. Let us look at the one that is not the same denominator. Let's say 2 over 5 plus 1 over 10. Now this time we don't have the same numbers, but we have one bigger than the other, which is also a multiple of the other one. So since 10 is a multiple of 5, I'm bound to pick the 10. Then how many 5 goes in 10? That's 2. 2 times 2 is going to give 4. Then how many 10 goes in 10? That's 1. 1 times 1 is going to give me 1. So the answer is going to be 5 over 10, which I can reduce to 1 over 2 if I divide both of them by 5. 5 divided by 5 gives 1. 10 divided by 5 gives 2. So it should be the same number we're using to divide them. Then the next fraction concept or addition of fraction concept is, let's say you have this number 4. You have let's say 5 over 12 plus 1 over 4. Yeah, it's still the same method. We are going to pick the biggest one because it's a multiple of the smaller one. So that's 12. How many 12 goes in 12? That's 1. That 1 times 5 is 5. Then how many 4 goes in 12? That's 3. That 3 times 1 is 3. Then the answer is 8 over 12. And you can divide both of them by 4. You can also divide it by 2, but 4 is the highest, so you divide it by the highest common factor. So you divide both of them by 4. 8 divided by 4 is going to give me 2. And 12 divided by 4 is going to give me 3. So your final answer is 2 over 3. Okay. We have another kind of addition of fraction. Let's say we have a 5. 2 over 9 plus 5 over, let's say 12 this time around, 12. So here we're going to look at two numbers, the two denominators. The biggest is 12, but it's not a multiple of this one. So here you're going to look for what's the next multiple of 12. That's 24, but it's not a multiple of 9, so you can't use 24. What's the next multiple after 24? That's 36. Yeah, 36 is a multiple of this, so you can use 36. Okay. So then you have how many 9 goes in 36? That's 4. 4 times 2 gives me 8. Then how many 12 goes in? That's 3. 3 times 5 gives me 15. So I can add 8 and 15 to get 23 over 36. And since 23 is a prime number, we cannot reduce it, and this becomes the answer. Alright, the next thing to talk about is proper fraction, improper fraction, and mixed number. When you say there's a small number over a big number, then it's a proper fraction. But when there is a big number over a small number, then it is improper fraction. But when there is a whole, like there's a number here, and there is another number and another number, like a whole number, no, like a whole number, then a number on top of another number, that is mixed number. So, excuse me. Example 1/8, small over big, small over big, small over big, small over big, b, small over big, and so on. Then we could use the opposite for this big over small. So example, I will not use 8/1 because 8/1 is 8, it's not a fraction. I will not use 10/2 because 10/2 gives me a whole number. So I will not consider it as an improper fraction. But I can use 17/5 because if I divide it, it will leave a remainder. I can use 100/3. I can use 60/11. And I can use 50/8 and so on. So where do we get this one from? It's pretty simple. The mixed number, we get it from improper fraction. So it's improper fraction that leads us to mixed number. How? Let's pick the first improper fraction here. Number 1, which is 17/5. We say how many 5 can go in 17? How many 5 goes in 17? That's 3, which is 15. Then it's going to remain 2. Then over 5. If you remove 15 from 17, you get 2 remaining. Then over 5. So that is how to get that done. Then let's pick the second one. 100/3. How many 3 goes in 100? Maybe that's too big. Let's cut it bit by bit. How many 3 goes in 10? That's 3, which is 9. 3 times 3 is 9. So remainder 1. We put the 1 here, making 10 again with that next 0. So how many 3 goes in 10 again? That's 3. Then it remains 1 now over 3. So that means the answer is 33, whole number 1/3. And the last one, or not the last one, 60/11. How many 11 goes in 60? That is 5, which is 55. If you remove 55 from 60, you have 5/11 remaining. I believe that should be clear. Then the next is, say, the last one, which is 50/8. So number 4, 50 divided by 8. How many 8 goes in 50? That'll be 8 times 6 is 48, so that's 6, remainder 2/8. This is the answer, but I can also say it is 1/4 because 2 and 8 can be divided by 2. 2 divided by 2 is 1. and 8 divided by 2 is 4. So that is how to change from improper fraction to mixed number. Why is it mixed number? Because there's a whole number and there's a fraction part, like whole number and fraction part. What if I have to change it back to this place? Okay, we're going to look at that shortly, changing from mixed number back to improper fraction. Just stay tuned. So what we want to do now is to change fraction from mixed numbers to improper fractions. Example, maybe you have 3 whole number 2 over 5. What you're going to do, because this is numerator and this is denominator, so you're going to use the denominator to multiply the whole number, which is 5 times 3. Then you add the numerator, which is 2. Then you divide it over the denominator, which is 5. So if you look at this, it's going to give us 5 times 3 gives 15, and 15 plus 2 gives 17 over 5. And that was one of the questions we looked at before. Okay, let's look at another example. Number 2. Maybe we have 5 whole number 3 over 8. So I said you take the denominator, which is 8, to multiply the whole number, which is 5. Then you add the numerator, which is 3. Then you divide everything by the denominator, which is 8. So 8 times 5 is what? 40. And 40 plus 3 is what? 43 over 8. There you go with your improper fraction. Okay, and the next one, number 3. Let's say you have 12 whole number 3 over 7. This is a method. 7 times 12 is 84. 84 plus 3 is 85 over 7. That's your answer. So if we do one more example, how to convert numbers from mixed numbers, convert fraction from mixed fraction to improper fraction. So you can have maybe 10 whole number 5 over 24. So we just say 24 times 10, that's 240. 240 plus 5 is 245 over 24. So that becomes the answer. Okay, now we need to talk briefly about decimal numbers. We wanted to look at fraction, decimal, and percentages. What are decimal numbers anyway? These are numbers that consist of decimal points, and they could have only decimals, or they could have both whole number part and decimal part. Examples of decimal numbers: we have 0.1, we have 0.01, 0 point anything, 0.583, 0.664, 7459, as whatever the number can be. And I said it could be decimals alone. All these are decimals alone, no whole number. That's why they are all 0 point, 0 point, and 0 point. But you could also have like 4.2 or any number, 30.08, just any number, like maybe 14 0.63, or like let's say 20.105, depending on anything. So these are decimal numbers. Okay, now we can add decimals. Yes, whenever we're adding decimals, we should always be careful with our place values. So adding decimals, we're going to pick some of these decimals to be added. Number 1, you want to add 0.1 plus 0.01. So to add it, you just align them together, like by saying 0.1 plus 0.01. Now you discover that the one above does not have 2 digits after the point, only 1 digit, but this has 2 digits. So you can replace it with 0. Then you add them together. This is 0 plus 1, and this is 1 plus 0. Then this is 0 plus 0. So your answer is 0.11. Number 2, let's say we want to add maybe whole number with decimal number, like 15 or 5 plus 3.6. So what we have to do is to write out 5 maybe at the top and write out 3 at the bottom, 0.6. Since the 5 doesn't have any point, you can introduce 0.0. Then 0 plus 6, 5 plus 3. Then the answer is 8.6. Also, we can say, let's say, we want to add another kind of decimal, maybe 4.2, number 3, 4.2 plus 0.583. Again, it's a decimal place value, so 4.2 plus the 0 point, so your points must align, then 583. Then since there is nothing beside this, we can put zeros. Then this is 3, this is 8, this is 7, and this is 4. So the answer is 4.783. Okay, let's see, maybe we had more. Let's say we have the number 4 to be this 30.08 plus 4.2. Oh, I said 30.08, not 3.08. 30.08 plus 4.2. So they are not the same decimal places. So we have 30.08, then we have 4.2. So you can see I didn't put anything under the 3 because this is just ones and this is 10. So, and I didn't put anything here, so I can put 0 here to balance up with that one. This is 8, this is 2, this is 4, and this is 3. So that is how to add decimal numbers together. Stay tuned. So changing fraction to decimal and decimal to fraction. Let's say example 1, you have 1 over 2 is a fraction. How can we change it to decimal? Obviously it's going to be 0 point something because 1 is smaller than 2. That's how many 2 goes in 1, then 0. It's not possible. Then you put a point here and put an imaginary 0 here to make 10. So you say how many 2 goes in 10? That's 5. So you'll agree with me that 0.5 is the same as half. 0.5 is the same as what? Half. Let's take a number 2. Let's assume you have 2 over 5. Now, you can see that 5 is bigger than 2, so 5 cannot divide 2. When we say how many 5 goes in 2, that is 0. We put a point. And you put an imaginary 0 here to make 20. How many 5 goes in 20? That's 4, and that's the answer. So, number 3. Let's assume you have 3 over 5. Again, how many 5 goes in 3? That's 0. How many 5 goes in 30? That's 6. So that's the answer to that one. Then number 4, let's say you have 1 over 5. So you say, how many 5 goes in 1? That's 0. And how many 5 goes in 10? That's 2. Or number 5, let's say you have 3 over 4. How many 4 goes in 3? That's 0. Put a point. If you put a 0 here, that's 30. How many 4 goes in 30? That's 7, which is 28. Remember 2. Then put a 0. How many 4 goes in 20? That's 5. That's 0.75. And number 6, let's say you have 3 over 8. How many 8 goes in 3? That's 0. If you write 30, how many 8 goes in 30? That's 3, which is 24. Remember 6. If you write 60, how many 8 goes in 60? That's 7, because 7 times 8 is 56. There remain 4. If you write 40, how many 8 goes in 40? That's 5. So that's how to convert from fraction to decimal. How about changing it back? Let's see. Number 1, we have 0.5. Because it's 0.5, how many digits after the decimal? That's 1 digit. Then you must divide whatever is there by 10 because it's 1 digit, so 1 0. Then you put the 5, and that's the answer, which you can change by dividing both of them by 5. 5 divided by 5 is 1, and 10 divided by 5 is 2. So it gave us to 1 over 2 from 0.5. Then number 2, we have 0.4. Again, it's 1 digit after decimal, so write 4 over 10, which is 2 over 5 if you divide them by 2. Then number 3, we have 0.6. So this is again 6 over 10 because it's 1 digit, and if you divide by 2, you get 3 over 5 if you divide both of them by 2. Then number 4, we have 0.2, which is also 2 over 10. Then if you divide both of them by 2, you get 1 over 5. Then number 5, we have 0.75. Now these are 2 digits. Then this is going to be 75 over 100 because it's 2 digits. That's why I'm putting 2 zeros. So you can cut it down by dividing them by 25. 25 goes in 75, that's 3. 25 goes in 100, that's 4. Then number 6, we have 0.375. You can see 3 digits after decimal. That is 375 over 1000. And if you cut it down, you're going to land 3 over 8. Now we want to look at fraction to percentage and decimal to percentage. If you have a fraction, say 1 over 2, and you want to change it to percentage, all you need to do is to multiply it by 100. So you can say 1 times 100 divided by 2, and that will give me 50%. You remember this 1 over 2 is the same as 0.5 in decimal. So to change it to percentage, simply say 0.5 times 100, and that will give us 50% if you multiply. Then number 2, 0.3, 3 over 4. To percentage, we can say this is 3 over 4 times 100, and this is 300 over 4. That will be 75%, because if you divide 300, or you divide 4, use 4 to divide 100, that will 25. 25 times 3 is 75. Then this 3 over 4, which is the same thing as 0.75. Want to change the percentage, you just say 0.75 times 100, and that will give you 75%, because multiplying by 100 means you shift your decimal point 2 times. So it's after the 5 now. Since there is no more digits, we'll leave it like that. Okay, what about 3 over 8? So percentage, we're going to say 3 over 8 times 100. So we can say 4 goes in 8, 2. That is 4 goes in 8, that's 2. Then 4 goes here, that's 25. So we have 25 times 3 divided by 2. That will be 75. 2. And how many 2 goes in 7? That's 3. 2 in 15, that's 7. So that will be 37.5%, or 37.5%. So the same thing with 0.375. To percentage means 0.375 times 100. So you shift your decimal point 2 steps. 1, 2, because I'm by 100. If it's by 10, you shift it only 1 step. So 1, 2 means 37.5. So 37, you now introduce your point and 5. So that will be 37.5%. 7.5. So this is how to convert between decimal, percentage, and fraction. Okay, we're going to continue shortly. So next is application of fractions and percentage. Okay, let's look at a few questions. Let's say if 2/3 of a dozen eggs costs let's say 2/3 cost $10. Okay, cost $10. How much is needed to buy 3 dozens? Now, let's think about it. You know what a dozen means? A dozen means 12 eggs. Dozen eggs mean 12 eggs. So we need to know 2/3. 2 over 3 of 12. Now this is allowing us to multiply fraction with whole number. So either you say 2 times 12, which is 24, then you divide by 3 to get 8. Or you say 3 here 1, 3 here 4. Now 2 times 4 is 8. So that means 8 eggs goes for $10. 8 eggs equal to $10. Then we can say 4 eggs must be $5. So if 4 eggs cost $5, another 4 eggs cost $5, another 4 eggs cost $5, then 4 plus 4 plus 4 is a dozen eggs, which is 12 eggs. So 12 eggs will cost, because 4 times 3 is 12, then that will be $5 times 3 for 1 dozen, and that will be how much? $15 for 12 eggs. Now, we are looking for the cost of 3 dozens, which is 36. So 3 dozens, which is 12 times 3, will cost $15 times 3. And the answer is $45. So that is applying, trying to apply fraction to situations. What about percentages? Let's quickly look at a quick question on that. Percentages. Number 2. If there are 300 girls in a school out of 1,000, say 300, okay, out of 2,400 students. So, what percentage are boys? So to do this, 300 out of 24, then multiply by 100 to get the percentage of the girls. Then, or you just subtract first, like boys equal to, okay, so boys equal to 2,400 minus 300, and that will be 2,100 boys. So the percentage will be the number of boys, 2,100, over the total number, 2,400, times 100. So that is the percentage of boys in the school. So 2 zeros cancel 100. Then you can divide 3 here 8 and 3 here 7. That is 700 divided by 8. If I divide by 4, I'm going to have, how many 4 goes in 7? That's 1, remainder 3. How many 4 goes in 30? That's 7, which is 28. How many in 20? That's 5. So 175 over, how many 4 goes in 8? That's 2. 175 over 2. So the final answer is going to be, how many 2 goes in 17? That's 8, which is 16, remainder 1. How many 2 goes in 15? That's 7. So it's 7.5%, because that remainder 1. Then you say how many 2 goes in 10? That's 5. So it's 7.5% of the school are boys. And it makes sense, because If 50% of the school are boys, then the number of boys and girls should be the same. But the number of girls are just 300, while the boys are 2,100. So way more, like 80%, close to 100%. Yeah. Okay, we're going to look at a little bit more concepts involving finding fractions or finding percentages. Just hold on. So we are trying to find fractions and percentages. Okay, let's assume you've been asked to take uh, to take 3/4 of 200 oranges to the market. So how many oranges will remain, or how many oranges will you take to the market? So how many oranges will you take to the, let me space this out. So will you take to the market? Okay, that's a question mark there. To solve this, you're going to find 3/4 of 200. So that means 3/4 times 200. So you could say 300, 3 times 200 is 600, 600 divided by 4, which is still okay, but you can also cut it through. 4 here 1, 4 in 20, that's 5, then there's a 0 there. So 50 times 3 is 150. How did I get that? 5 times 3 is 15. Then I put the remaining 0 there to get 150. Take note. So, and then number 2, let's say you're looking for what is 30% of 600. What is 30% of 600? So all you need to do is to say 30%. 30% means 30 over 100, then times 600. So doing this, we 2 zeros got 2 zeros, and 3 times 6 is 18. Then you put the 0, that'll be 180. That is 180 is 30% of 600. What about 50% of 600? That's 300, and so on and so forth. And 100% of 600 is 600. Just take note of that. Hold on, we're going to continue shortly. Alright, so we're rounding up now. Just a quick recap. We've been talking about fractions all along, and we know that a fraction is part of something, part of a whole. Then examples of adding fractions: we added this with the same denominator, which we just had the number at the top. Then we added the one with different denominator, which we have to pick the biggest one. If it's a multiple of the smaller one, then we say 5 goes in 10, that's 2, 2 times 2 is 4, 10 in 10 that's 1, 1 times 1 is this. Then we have another one with different denominators, bigger one and smaller one. The bigger one is a multiple of the smaller one, so we have 12. But here 9 and 12, the bigger one 12 is not a multiple of the smaller one, so we have to look for the next multiple of 12. That will be a multiple of 9 before we can go ahead. So next one is 24, it won't work, but the next one is 36 and it works. So how many 9 goes in 36? That's 4. 4 times 2 is 8. 12 in 36, that's 3. 3 times 5 is 15. And when you add this, you get 23 over 36. Okay. You can subscribe to this channel